Let's talk about the ideal gas law. We'll identify the mathematical relationships between various properties of gases, and then we'll use the ideal gas law to compute various gas properties under specified conditions. Gas laws define relationships between various measurements of gases. Remember when I said that pressure was related to the number of molecules hitting you, how heavy they are, and how fast they're going? We'll apply these ideas. We'll start with the effect of adding more molecules. So, the weird-looking truncated infinity symbol is for proportionality. Volume is proportional to moles. Moles given as lowercase n. Therefore, as moles goes up, so does the volume, as long as pressure and temperature are constant. So, at some point in your life, you've probably blown up a balloon. What are you putting into the balloon to make it bigger? Air from your lungs. So, as you added moles of gas to the balloon, it got bigger. Volume is inversely proportional to pressure. If you push down a piston, what happens to the volume of the container? It gets smaller. So when you press on the gas molecules, they're forced closer together so that the force on the inside of the container is equal to the force applied to the outside of the container. This is if moles and temperature are constant. So volume inversely proportional to pressure. Finally, volume is proportional to temperature. As temperature goes up, volume goes up. Most of us have seen hot air balloons at some point or other in a video or in real life. How do they inflate those balloons? You may never have seen this, but it's actually really cool. They blow hot air into the balloon. The brave people who have circumnavigated the globe in hot air balloons have all flown high during the day and low during the night due to the temperature fluctuations between night and day. We can put all of these together into one thing. That's called the ideal or combined gas law, PV equals nRT, which I remember as PIV-NERT, but most of my classmates in high school remembered it as pervert. Use whatever works for you. If variables are on the same side of an equation, they are inversely proportional. If they're on opposite sides, the variables are directly proportional. So what do I mean by that? Inversely proportional means that as one goes up, the other goes down. Directly proportional means that as one goes up, so does the other one. P is pressure, V is volume, N is moles, T is temperature in Kelvin, specifically in Kelvin. I'm going to keep saying in Kelvin. And R is the ideal gas constant. It's a constant, it's a fixed thing, it's always going to be the same thing, but you can have different units, so it has different values based on the units. Generally, for this unit, we will use R as 0.0821 liters atmosphere per Kelvin mole. But for other applications, we might need things in joules, so we would use 8.314 joules per Kelvin mole. Whichever thing you use, make sure that your units balance. Now, this is 4 variables and 1 constant to keep track of for one single equation, which can be a little bit confusing. So let's try using this equation and we'll talk about how we can organize our information. What is the temperature of 0.5 moles of gas with a pressure of 0.95 atmospheres and a volume of 2.5 liters? So we've got 3 variables. We're trying to solve for temperature in our PV equals nRT. So what I do is I go through and I take all my variables and put what they're equal to before I do anything else. So this organizes my information. So I have pressure is equal to 0.95 atmospheres. I have volume is 2.5 liters. I have N is 3 mole or 0.5 moles. And I have R is 0.0821 liters atmosphere per Kelvin mole. I will now plug that into my equation. I have looked at it and said, oh, everything will cancel out except for Kelvin. That's what I want. Cool. So I put that in and I solve for T and I get 58 Kelvin. So this is not a particularly difficult process per se, but you do need to make sure that you have accurately identified what each variable is and that your units will actually cancel, or you will definitely get the wrong answer. Sometimes we change conditions. We don't always keep everything the same. So when we do that, we need an equation to relate those sets of conditions. We're going to start with the ideal gas law, and we're going to work our way up to a different version of the ideal gas law. So PV equals nRT. If I divide both sides of the equation by nRT, on the right, nRT over nRT reduces to 1. So if PV over nRT is equal to 1, then it doesn't matter if I've changed conditions, PV over nRT will be the same value. And R will cancel because it's a constant on both sides. So I find that P1V1 over N1T1 is equal to P2V2 over N2T2. A lot of you will memorize this. I never did. I just remembered how to do that little mathematical trick, and I was golden. But again, we have a lot of variables, and we don't necessarily have to change multiple things. We can use this for literally every time we change values. So let's get into how we would do that. And a container has 1 mole of gas and a volume of 2 liters. It expands to a volume of 3.5 liters at a constant temperature and pressure. How many moles of gas are there in the container at the end? Okay, so I lay out my variables. I have my V1 is 2 liters, my N1 is 1 mole, my V2 is 3.5 liters, and I'm looking for my N2. And so I go and I take that P1 V1 over N1 T1, etc. equation, and whenever something is the same on both sides, I can cancel it out. So we have a constant temperature. Temperature will be the same on both sides. It cancels out. We have a constant pressure. Pressure is the same on both sides. That cancels out. We can get to any version of this where we're changing two things and we'll be fine. Just cancel out the stuff that's constant on both sides. All right, so then I plug in my variables and I solve for N2 and I get 1.75 moles. Again, this is not particularly difficult, but you do have to keep track of your variables and make sure that your sets stay together. If one pressure goes with one volume, keep it together. Otherwise, you will get the equation wrong. And finally, make sure your units match. I will tell you that will be a pain in your arse by the end of this unit. You'll be like, ugh, another unit conversion. It happens. To summarize, the ideal gas law says that PV equals nRT, where P is pressure, V is volume, N is moles, T is temperature in Kelvin, again, in Kelvin, and R is the ideal gas constant. If the variable is on the same side, it is inversely proportional. As one goes up, the other one goes down. If a variable is on the opposite side, it is directly proportional. As one goes up, the other one goes up. And you can combine the ideal gas law for changing conditions by saying P1V1 over N1T1 equals P2V2 over N2T2. When you use that equation, you can cancel out anything that is held constant.